So let's get going. Julian, have a seat. Right? Sign in, have a seat. Time to stop talking. Mike.
Yeah.
Right?
Yeah.
So today's lesson is about a certain kind of linear function, which is called direct variation. And so a direct variation, which we had one in the homework. Remember the one that was y equals 2/3 x? The y-intercept was 0, so the graph went right through the origin?
Yeah.
That's a direct variation. Whenever the y-intercept is 0, that's called direct variation. Because the only thing that's going to change the position of y is the slope. You're not also going to be adding or subtracting numbers the y-intercept. So y equals mx plus b just turns into y equals mx because the y-intercept is 0. Now the SOLs, they don't keep it as an m. They call it k. Right? That's what the SOLs do. In fact, that's what almost every math textbook will do, is they're going to call that a k. And this textbook, if you happen to look in there because you weren't paying attention in class, is going to use a. They don't say k, they say a. And that I've never seen before. It's usually k. And whether or not it's m or k or a, it's all the slope, and that's called the constant of variation. Right? Constant of variation. You know, what does it mean to say that it's constant? It doesn't change, right? X and y are variables, right? We know that we're going to have infinitely many points. All of them have different x and y values, right? They change. They're variables. They vary. But k is a constant, or a, or m. That's a constant. It doesn't change. We use a letter to represent it because, you know, to be general, we don't know what the value is, maybe when we start the problem. But it is a constant. Its value doesn't change. Okay, so tell whether the equation represents direct variation. And if so, identify the constant of variation. Okay, so what you have to do is solve for y. Right? Again, more kind of review for the quiz tomorrow. How do I solve that for y? Minus 2x, right? If it's a positive on the right, it's a negative on a positive on the left, it's a negative on the right. Okay, next. Divide by -3. Divide by -3. Okay, so on the left we just have y. How does the right side simplify? Positive 2/3 x. Okay, now that it's solved for y, you can answer the question. Is it a direct variation? And again, what are you looking for that would tell you it's direct variation? B equals 0. The y-intercept equals 0. So what is the y-intercept of that? 0, right? So B equals 0, so that is, yes, direct variation. And what is the constant of variation? Right? And the constant of variation equals 2/3. It's the slope. Right? Pretty easy. You just have to solve for y, right? That's why we keep practicing this solve for y. Okay? So same thing. How do I solve that one? Plus x, right? Because to solve for y, you need to move that negative x. If it's a negative on the left, what is it going to be on the right? Positive. X plus 4. Is that a direct variation? Felicity? Why do you say it's a no? Yeah. B does not equal 0, therefore not direct variation. Which means you don't have to do the second part, right? Because it's not a direct variation. It doesn't have a constant. So here's your first U try. Right? Solve for y, and then tell whether or not it's a direct variation. Is it a direct variation? So what did you get when you solved for y? X plus 1. Right, so that is, because of that 1 right there, right, you're going to say not direct variation. And I'm just going to abbreviate, not dv. Okay? Yeah. Yes? Because a direct variation has a y-intercept of 0. So this has a y-intercept of 1, so it can't be direct variation. Direct variations have a y-intercept of 0. That's the only thing we're looking at here, right? Does it have that? Okay, try this one. So what did you say? Is it a dv? So when you solved it, you got y equals negative 2x, right? Which has a slope of negative 2 and a y-intercept of 0. So yes, that's a dv. Yes. dv k equals, what's the constant? Negative 2. Right? Easy stuff so far, right? Okay, try the same thing with that. So what'd you say? Was it direct variation? I mean, if you solve for y, first step, minus 4x. So if it's a plus 4x on the left, it's a minus 4x on the right. Then you divide by negative 5. Negative 5. So y equals positive 4/5 x. So you say, because the b equals 0, you say yes, that's a dv. And k equals what? Not x. It's just the number in front. So if you notice, and I think we just did 5 of these. Actually, you did 3, and then I did 2. So before you ever solve, you can tell whether it's going to be a direct variation to see, like, if the only constant you see on the right side is a 0, that's going to be a direct variation. This one had a 4, not a direct variation. That one had a 1, not a direct variation. That one had a 0, direct variation. That one had a 0, direct variation. I mean, you can answer that part of the question without solving, but you won't get the k unless you solve for y. Okay. So graphs of direct variations always go through the origin. Right? The graph on the left is direct variation because it goes through the origin. The graph on the right is not a direct variation. Here's a typical kind of question they have on the SOLs. They'll say, here's a point on a direct variation. Right there. Not that direct variation, but use your cursors, not a multiple choice question. Click on another point on the direct variation. So if that's one point, where's another point? The origin. So you click on the origin. I mean, I've seen them ask a question 2 different ways. Once they'll say just like that, you need 1 extra point, and that could clearly be the origin. And another one that said give 2 extra points. So if the origin was 1 point, then you would want to just stay on the same line. So it looks like it's up 3, left 2, it'll go up 3, left 2. So just as long as it's on the same line, there's your 2 points. But I'd say there's usually about 4 or 5 questions about variations, and one of them, that's the thing you got to know. If you understand that 1 point, you're going to get that question right. Okay, so graph the direct variation. Okay, well, for us at this point, I'm just going to graph it like a slope-intercept form. It just, what is the intercept? It's 0. So the first point is always going to be there, and now use the slope to find another point. So if the m equals 2/3, the 2 is telling you to go up, and the 3 is telling you to go right. So up 2, right 3, and draw yourself a line. An infinite line. Okay? Again, what's the first point I'm going to graph? 0. Okay? And the slope is -3. So how is that telling me to get to the next point? Down. And I prefer to say right or left than over, because over doesn't really tell you. Right? So down 3, right 1, there. And there's my graph. Not a very good graph. That's oh, come on. You get the point. You get the point. Okay, so you try to graph that direct variation. Okay. So what is the slope? 2 over 1. Up 2, right 1. Draw the line. Makes sense? Okay. Now, so what if this case they're saying, here's the graph of a direct variation, and we can see it is because it goes through the origin, but they're not giving us the equation. They want us to figure out the equation. Okay, well, let's see. We know that the equation is y equals some kind of a constant times x. We can even just let's call it mx. So the only thing we need to be able to tell from this graph is what's the slope. Okay, yeah, in fact, it's just 2 over -1. You go down 2, you either go up 2 and left 1, you go down 2 and right 1. The m equals -2 over +1, which is -2. So the equation is y equals -2x. Okay, then you can answer the question. Find the value of y when x equals 30. How are we going to find the value? You're going to take that 30 and you're going to plug it in there. So y equals -2 times 30, which is -60. This one is a graph. In the book, the example I took it from, it was a graph, so I made a graph. The U-try is not a graph. Now, if it helps, you could make yourself a graph. Oh, did I not make that? That was your U-try. This is your U-try. Okay, the graph of a direct variation passes through the point 4, 6. Write the equation and find the value of y when x equals 24. Remember, since the only thing you need to know is slope, maybe you want to know the formula for slope. And definitely this could be one point, and then what would be another point you would plug into the formula? What point is always on a direct variation? 0, 0, right? So, I mean, if you wanted to go through that process, I mean, it will kind of point out how you can do this pretty easily. Right. So in the end, because one point is 0, 0, it's really, you could just take the y and divide it by x. That is always how you can find the constant in a direct variation. This is what's y divided by x. And 6 over 4 could be simplified to 3 halves. So here's our direct variation equation. Y equals 3 halves x. Okay, now answer the question. Find the value of y when x equals 24. Okay, y equals 3 halves times 24. Again, you could put that in the calculator, or you could say 2 goes into 24 how many times? And 3 times 12 is 36. Okay. Now, the next is a word problem. Right, the number of tablespoons of sea salt, which is we're going to use the letter S for that, needed in a saltwater fish tank varies directly with the number of gallons of water, that'll use lowercase w to represent that, in the tank. Write the direct variation equation that relates S and W. How many tablespoons of salt should be added to a 30-gallon fish tank? Just a second. I'm missing a data point in there, obviously. Yeah, I'll add it in the next. What I wanted to make a point of is, notice they use the words varies directly. On the SOLs, they're probably more likely to say is proportional to. Or they might even say is directly proportional to. So we're supposed to know whether they say it the one way or the other. It's a direct variation, right? But a lot of times it's proportional is the word they use. So the one thing that I neglected to say here, which I can add, it says that the pet shop owner recommends adding 100 tablespoons of sea salt to the 20-gallon tank. Say, pet shop owner recommends adding 100 tablespoons of sea salt to a 20-gallon tank. Okay. So what's going to be the equation? I mean, you know, usually we say it's like y equals kx. Okay, but we're not using x and y. We're using s and w. So which one is going to go in the place of y? Which one goes in place of x? Which one depends on the other? Does the amount of water you have in the tank depend on the amount of salt you put in? Or does the amount of salt you have in depend on the amount of water in the tank? Salt depends on water, right? So y depends on x. So it should be the amount of salt equals whatever our constant is times the amount of water. Okay? So now for our constant, remember, so this thing here, if the w is like the x, then this is our point, 20 comma 100. So what is the constant? K equals, remember how we just did on the last one? It's the y divided by the x. In this case, it'll be the w the s divided by the w. So it'll be 100 divided by 20, which is 5. So here's our direct variation, right? S equals 5 times w. Okay, now they want to know how many tablespoons of salt should be added to a 30-gallon saltwater fish tank. What do I do with the 30? You plug it in right there, right? So yes, you times it by 5. 5 times 30 is 150. 150 tablespoons of sea salt. I mean, this is the kind of stuff like, you go to the doctor and he prescribes medicine, he may be giving you something. It's based on your weight. I mean, it's a direct variation. If somebody's twice as big as somebody else, they might get twice as much of the drug. Connor. Is it like a proportion? Yeah, I mean, it is proportional. Proportional means that it has the same ratio no matter what. So, I mean, we didn't really have this in here, but for example, if you have y equals kx, if I solve that for k, I get k equals y divided by x. Now, we know k is a constant. Y and x change all the time. But what we know is their ratio is always the same. So we could set up proportions like, 4 is to 2, as 8 is to 4, as 10 is to 5. They're proportional. That means they're proportional. So you're right about that. Okay. And last thing. This table shows the cost C of downloading S songs at an internet music site. Is it a direct variation? If so, write the equation. Okay, so C might be a direct variation with S, which is the number of songs. Right? How do we know whether it is? Right? If it is, then C divided by S should always give us the same value. So use your calculator and tell me, what is 2.97 divided by 3? Right? Calculator time. (2.97) divided by 3. 0.99. Okay, try 4.95 divided by 5. Okay, try the last one. 6.93 divided by 7. 0.99. So it's because every time you divided the C by the S, you always got the same thing. That means it's a direct variation. So we're going to say, is it a direct variation? Yes. And the equation should be C equals 0.99S. So it looks like you're paying 99 cents per song. And that's actually not that bad. I mean, it's not too far off of what it is today, right? I mean, considering this book was written like 10 years ago, probably before iTunes or anything.
They had iTunes like 99.
I don't know if it was 99. And in the early 2000s, people were using Napster, and there wasn't any other option. But so there's your homework. Oh, okay. We'll just see.
Yes, homework. Got it.